guys, it's Coach Kaufman here, and we are going to talk about Unit 9.1, just some introduction to our polygons unit. So we've got this chart, hopefully you've already written it down, and it just talks about the names of these polygons. So obviously we've talked a lot about triangles this year, so it just has 3 sides, it's called a triangle. Any 4-sided shape is a quadrilateral, 5 sides a pentagon, so on and so forth. One thing I do want to point out is that you can name any shape by the number of sides. So like, for example, this a 13gon. We're just going to call it a 13gon and not give it a name because you can name it like that. So 13 and 11 are written like that. All of these other names have common specific nicknames that we're going to use. All right, but any shape that is greater than a dodecagon, so like a 15-sided shape would be called a 15gon, or a 18-sided shape would be called an 18gon. And you just plug in the number of sides right there. Okay? Some vocabulary that's pretty important you need to make sure you have written down. It's just talking about a polygon. So it's really just any shape that doesn't have crazy sides sticking out anywhere. It doesn't have any curved sides. It just has to be a closed figure with straight sides. And then a regular polygon, which we're going to use this a lot. So you need to make sure that you know what a regular polygon is. And it is a side, or it is a convex polygon, which we'll get to that word in just a second. But all of the side lengths and the angle measurements are congruent. So we're going to talk about that later on, a regular polygon, and that's what it means. So you can come back and reference this. All right, for concave, it's just going to be a polygon that we're going to call it caves in. I'm going to put that in quotes there. But a concave shape is a shape that caves in. So, thinking of a polygon that caves in, a star, which I'm not very good at drawing stars, so we're just going to go with it. Oh, that's ugly looking. But a star is a shape that caves in. Or like Pac-Man would be a shape that caves in. So it's still a 1, 2, 3, 4, 5, 6-sided shape. It is still a polygon, but it caves in. Okay? Just imagine that all of these sides are straight. For convex, it is going to be a polygon. It's a polygon with no dents or indentations. Okay. So we can just think of it as all of these sides point out. All of these vertices point outwards. See, some of these vertices point inwards. For this one, all of them point outwards. Like a 6-sided shape. I want to be very specific and not draw all the same sides the same length, because that would be a regular polygon, but it can be convex and not regular. Okay, but a regular polygon must be convex, so that is important. We're going to go to the next. All right, so there are some important formulas you need to know. There are 4 total formulas. 2 of them are advanced formulas, but we are going to start off by talking about this one. So this is the sum of the interior angles. Sum would mean everything added together. So all interior angles added together. So that's important for this. It's the sum for all of the interior angles added together. something that's very important, this hint, is that n stands for the number of sides. So like if this was a pentagon, which is 5 sides, you would take a 5 and plug that in there, and it'd be 5 minus 2 times 180. Okay, and we'll get to that in the examples. All right, this one is how to find one interior angle. So notice before it was all of the interior angles added together. This is just one interior angle. If you notice, it's the exact same as this formula. You just do that formula and then divide by the number of sides. Okay, that's the only difference there. All right, the sum of the exterior angles, which this is very important, but the sum of the exterior angles all add up to 360 degrees. Okay, so an exterior angle is going to look like this. So like a quadrilateral, an exterior angle would just extend the sides further out. And then all of these would be exterior angles. Just extend the side. Okay, if I drew a pentagon, it would look like this, and we would extend all of these side lengths. And those would be the 5 exterior angles. So if you want the sum of the exterior angles, they will always add up to 360, no matter what. So it can have 100 sides, and the exterior angles will still add up to 360. Because the more sides, the smaller each exterior angle becomes. Okay, so if we want to find the value for one exterior angle of a regular polygon, so it only works for regular polygons. Same up here, regular polygons. Should have underlined that. Then you would just take 360 and you divide it by the number of sides. All right, now we're going to do this example. We're going to find the sum of the measures of the interior angles of a regular pentagon. So the sum of those angles is going to be the number of sides minus 2 times 180. Okay, so a pentagon has 5 sides, which we can see right there. So I've got my formula, n minus 2 times 180, and I just need to plug 5 in. So when I plug that in, I get 5 minus 2 times 180, which is 3 times 180, which equals 540. Okay, so that's the first one. Pretty simple. Okay, and then for this one, make sure it says 720 here and not 560. That was a typo. But we want the sum of the measures of the polygon. So we want to take that formula that we just did, n minus 2 times 180. That's going to equal 720 degrees. And so to get n all by itself, we want to divide by 180 on both sides. So n minus 2 is going to equal 720 divided by 180, so 4. But don't stop there, because we want to figure out what n is, so we need to add 2 on both sides. So n is 6. Great, but it doesn't say how many sides. It says classify the polygon by the number of sides. So we have to figure out what's the name of the shape with 6 sides. That's going to just be that. So you type, or you write in hexagon. Okay. So for example 3, we we want to find the value of one interior angle of a regular hexagon. So we're just going to use that formula that was on the page before. One interior angle of a regular polygon. I'm going to write that down. N minus 2 times 180 divided by n. And then we need to plug the number of sides for a hexagon, which is 6. So 6 minus 2 times 180 divided by 6. Okay, I like to just go ahead and solve out. 6 minus 2 is 4. So 4 times 180 would be 720. So we get 720. And then we want to divide that number by 6. Oh, not 2. So you get 120. So what did we just figure out? We found the value of one interior angle of a regular hexagon. It's 120 degrees. Alright, before I move on to the advanced problems, I've got one more type of problem that I'm going to show you in the Pear Deck. Okay, so here's the picture right here. I've actually drawn it on my piece of paper. If you come to class, we will do this on the Nearpod. But I want you to draw this on your paper, so pause and draw it on your paper. Okay, and I have this drawn on mine. So what we are going to do is figure out how to solve for x. So our first step is to determine the angle sum. So write that, determine the angle sum. Okay, how do we do that? N minus 2 times 180. How many sides is this shape? 1, 2, 3, 4, 5, 6. So 6 minus 2 times 180. So it'll be 4 times 180. So 720. Hopefully you're noticing that all hexagons have an angle sum of 720. Yeah, it's a pattern that they all follow. So now all you have to do is add angles and set equal, if I get right, set equal to the angle sum. And then 3 is solve. Okay, so here's my angle sum. I'm going to add all these: x plus 140 plus 130 plus 120 plus 90 plus 150 plus, I don't know why I added that 90, because I'm crazy. Thank goodness for whiteout. So I've got 1, 2, 3, 4, 5, 6 angles equal to 720. I'm going to add all these together, 140 plus 130. I'm just combining like terms. Oh, doesn't make sense. 90 plus, oh, there's my husband. Struggling. So 630 x plus 630 equals 720. And then I'll subtract 630 on both sides. And x will be 90. And then I'll do the advanced problems, and that'll be all. Okay, and then the last two problems on here are the advanced problems. So this gives us the value of one interior angle of a polygon, right there. So what we need to do is we need to take the formula for one interior angle of a polygon and set it equal to that number. So what we're doing is we need to solve for n. But we don't like fractions. We want to get rid of that. And this is kind of going to look like cross multiplying. So we're going to multiply 135 in n, and then this part of the equation just is multiplied by 1. So n minus 2 times 180 is going to be equal to 135 n. Okay? So this will look a little bit different, because then when we solved one similar to this, we're going to go ahead and distribute. And I know it looks weird because the 180 is on this side of the parentheses. Usually it's over here, but it doesn't matter. So we're going to do 180 times n minus 360, and that's going to equal 135n. Then subtract 180 on both sides, 180n from both sides. So negative 360 equals, well, this is going to be a negative because it's negative 135 and negative 180, so negative 45n. So 135 minus 180 is negative 45. And then divide by negative 45 on both sides. 360 divided by 45. And those two negatives cancel out. So it's n equals 8. Alright, but it wants us to classify the polygon. So we're not just solving for n. We are taking 8 and figuring out which shape it is, which it is an octagon, an 8-sided shape. Okay? Alright, and then the last example, find the value of one exterior angle of a dodecagon. This one's super simple. So exterior angles are always equal to 360. Alright? Exterior angles equal to 360. So, to find the value of one exterior angle, we need to take 360 and we need to divide it by the number of sides. And a dodecagon has 12 sides, so we would say 360 divided by 12. So each exterior angle of a dodecagon would be 30. And this one, actually, I need to change the wording for this. Didn't realize this. Find the value of one exterior angle of a regular dodecagon. So that's important. I know this didn't have the word regular in your notes, but just make sure you put the word regular, because that's where all the angles and sides are equal the same. So it would need to be a regular dodecagon for all of them to equal 30. Okay? Alright, that's it.